In this video, we're going to be talking about some basic terminology that you will see in your algebra class, and we'll be looking at some examples of how to use the order of operations when dealing with integers. So a variable is a letter that represents a number whose value may change. A constant is a number whose value always stays the same. So a variable, we often use a letter, could be like x. A constant is just a number, like 8. So you may see some kind of expression, 3x plus 8. 8 is called the constant, and it's because it's by itself. It's not multiplied by a variable, so 8 is just 8. 3x, however, is a variable term. It has a variable next to the 3, so it's not just 3, it's 3 times whatever x is. So it varies based on the value of x. So that's a variable term. X is the variable, 8 is the constant. Some commonly used symbols. We have addition, subtraction, multiplication, and division. So these are all operators. Our operation symbols. We have equality, so equal to, so that's an equality symbol. And then we have not equal to, less than or equal to, greater than or equal to. Those are all inequality symbols. So the two sides of the inequality have a relationship. They're just not equal to one another. So we could say they're not equal to each other. We could say one is less than the other, or one is greater than the other. But some kind of relationship other than equality. So these are inequality symbols. And then we have grouping symbols. So all of these are known as grouping symbols. They all look different, but they can all be used like parentheses. So those are some symbols or operators that you will see throughout your course. Oh, and let me just share. If you are one of the people who get confused with which one is a less than sign and which one is a greater than sign, the one that looks like an L is less than. So the L stands for less than. So you can see that that one does not make an L. The one that looks like it can make an L is the less than symbol. Okay, so a few more terminology terms here. We have an expression. That's a number, a variable, or a combination of numbers and variables using operation symbols. So let me give you an example. This might be like 3x squared plus 2x minus 1. That's an expression. An equation is two expressions connected by an equal sign. So I would have an expression over here equals some expression over here. That would be an equation because of the equal sign. You can see that you have an expression on the left and you have an expression on the right, and they're connected by this equal sign. So that's an equation. And then finally you have an inequality. This is two expressions connected by an inequality symbol, and it could be any inequality symbol. So 5x is less than 10 would be an example. It could be, what's another example? Negative 3y squared is not equal to 15. That would be another inequality because it's a not equal to. So anything that you can join two expressions with one of those inequality symbols would be considered an inequality. Next, we have exponential notation. So a to the n means multiply a by itself n times. So a is called the base, n is called the exponent, and a is what you're multiplying by itself n times. You can say you have n factors of a. The expression can be read a to the nth power. We will see some examples in a minute. All right, order of operations. So whenever you see an expression, we all need to make sure that we're working it in the same way so that we can arrive at the same answer each time. And the way we do that is we use the order of operations. A lot of people might remember it as PEMDAS or please excuse my dear Aunt Sally. So those are both good ways to remember the order of operation. The important thing to note is that if you've ever seen it written like this, it's not giving you the full picture. Notice that I have it written where M and D are on the same level. That's because they are equal operations. Once you have all multiplication and division, you multiply from left to right. So if division comes first and then multiplication, you would do division before multiplication. So multiplication does not come first. Division and multiplication are equal. The same is true for addition and subtraction. So addition and subtraction are equal operations. So if you have an expression with all addition and subtraction, you would work from left to right. So if subtraction came before addition, you would do subtraction before addition. Whatever comes first from left to right is what you would do if it's all addition and subtraction. Hopefully we'll see some examples that will illustrate this point. So for the first one, this is our example with the exponential notation or an exponent. So 2 is the base, 3 is the exponent. This means we have 3 factors of 2. In other words, we're multiplying 2 times itself 3 times. 2 times 2 times 2 is 8. If you're in a rush, you might do 2 times 3 is 6. So be careful. Make sure you realize that you're doing 2 times 2 is 4, times 2 is 8. For number 2, we have 3 squared minus 18 divided by 11 minus 5. So the first thing I want to do is look for parentheses. We have our PEMDAS, right? Parentheses is first. So I do have something in parentheses that I can do. I have 11 minus 5. So that's my first step. So I'll do 3 squared minus 18 divided by 11 minus 5 is 6. Okay, now I've done parentheses. There are no more parentheses. So the next thing I look for is exponents. I do have an exponent, so I'm going to take care of that next. So 3 squared is 9, and I bring down everything else. So I'll have 9 minus 18 divided by 6. Next in my order of operations is multiplication or division. So I can see that I do have a division. So I have negative 18 divided by 6. So I'm going to bring down the 9, and negative 18 divided by 6 is a negative 3. And now I'm just left with subtraction. That's the last part of our order of operations, so I'm going to do that. And 9 minus 3 is 6. If you did not follow the order of operations, you might end up getting the wrong answer. Some of you may have done the exponents and the parentheses in the same step, and you would get 9 minus 18 divided by 6. And you'll see that that's the same thing we have here. And that's okay, and the reason it's okay to do both of those things at the same time is because they don't interact with one another. They're totally separate. But in order to be clear, I want to make sure I do every single thing in the proper order. Okay, so next we have number 3. So first, parentheses is what we look for, and I do have something in parentheses. So I'm going to start by doing that subtraction. So 2 plus 8 times 5. All right, so next I have exponents. I don't have any in this expression. So the next thing I look for is multiplication or division. I do have that right here. So 8 times 5 is 40. So I'll have 2 plus 40. And then lastly, I look for addition and subtraction. Got addition. So 40 plus 2 is 42. And that's it. Okay, so if you haven't yet, I would suggest pausing and trying these on your own. If you want to do one at a time, try it and then watch and check. Fantastic. That'll give you some, trial and error to make sure you know how to do it yourself. So number 4, we're looking for parentheses first. Whoops. So I've got all of this in parentheses. Within the parentheses, we now have to figure out what to do first. So inside the parentheses, we don't have more parentheses. We don't have exponents. We have multiplication and division. So I'm going to have to do that first. So 3 times 1 plus 9 times 6 is 54 minus 4 squared. I still have more to do within the parentheses. I still need to do that. So I'm going to add those. So I will get 3 times 55 minus 4 squared. Okay, so now I've finished with parentheses. The next thing I want to do is exponents. I do have exponents. I have a 4 squared. Notice that I didn't say negative 4 squared. The only thing that's squared here is the 4. And here's where you're going to see the difference. So negative 4 squared versus negative 4 squared. So if you don't have parentheses, the only thing that's squared is exactly what's in front of the 2. So the base here is 4. If you have parentheses, everything in the parentheses is raised to the second power. So in this second case, the base is a negative 4. So everything in parentheses is part of the base. So it's 2 different scenarios. In the first scenario, you have a negative. The only thing that's raised to the second power is 4. So it's a negative, bring down the negative, 4 times 4. That's a negative 16. Whereas if you have it in parentheses, this means a negative 4 times a negative 4. 2 negatives make a positive. So in this case, you actually have a positive 16. So the parentheses make a huge difference. In this case, example 4, we don't have parentheses. So we're going to end up with 3 times 55 minus 16. Now we're going to move on to the next step of order of operations. That's multiplication and division. We do have some multiplication. So 3 times 55 we get 165 minus 16. And then the last part of order of operations is addition and subtraction. And we have subtraction. So 165 minus 16 gives us 149. So that would be the answer to that one. All right, number 5. We're going to work in parentheses first. The key here is that we have this set of parentheses. So everything in here is part of that set of parentheses. But within those parentheses, we have more parentheses. So we have to work the innermost parentheses first. So that's where I'm going to start. So this is going to be 2, 1 plus 3, and then I'm going to do what's in parentheses. 10 minus 2 is 8. Okay, so now inside the brackets, so these are called brackets instead of parentheses, or they're called square brackets. Inside the square brackets, we have addition and we have multiplication. So our order of operations say that multiplication would come before addition. So we're going to do that. So we'll have 2 times 1 plus 3 times 8 is 24. We're still working within the parentheses. So I'm going to do 1 plus 24. So it's going to be 2 times 25. And now, again, it is multiplication here. The square brackets act like parentheses. So I've got multiplication. 2 times 25 would be 50. Number 6. So these are getting more and more complicated. So the more practice, the better. There is extra practice available. Here's the link to the textbook that I used for some of these examples. You can go here and find more examples to practice with and more explanation. So if you need more than what's available here, there are extra practice problems at this website, this free OpenStax textbook, and they actually have the answers to the to the odd problems. So you can actually work them and try them out and check your answer. Okay, so number 6, we start with parentheses. So anything that has an operation inside parentheses. So this 2 squared is not considered parentheses because there's nothing inside the parentheses to do. This is considered parentheses because it has an operation inside the parentheses. So that's going to be the first thing that we do. So 3 times 2 squared minus 3 times 2 is 6 minus 4 over 8 minus 12 divided by 2. Okay, next I'm going to look for exponents. I see an exponent here. The only thing that's raised to the second power is that 2, so the 2 is the base. So I'm going to take care of that next. So 2 squared is 4, so 3 times 4 minus 6 minus 4 all over 8 minus 12 divided by 2. Next is multiplication and division. So I have this multiplication up here, and I have this division down here. Now, be really clear. This fraction bar is a division symbol. It means division. But you don't do that division until the very end. You simplify the numerator by itself all the way, and you simplify the denominator all the way by itself. And then when you're finished simplifying the numerator and the denominator as much as you can, then you can divide those numbers. But you don't do that till the very end. So the numerator has to be simplified all the way, and the denominator has to be simplified all the way. And then you can put them together. Okay, so we're still simplifying the numerator and denominator. We're looking for multiplication and division. So in the numerator, I have 3 times 4. So that's going to become 12. I'm going to bring down the minus 6 and the minus 4. In the denominator, I have that division. 12 divided by 2 is 6. So I'm going to have 8 minus 6 in the denominator. Now I want to take care of any addition or subtraction that I have in the numerator or the denominator. And I can see that it's all subtraction. So when I take care of that, I have 12 minus 6 is 6, and 6 minus 4 is 2. And in the denominator, I have 8 minus 6 is 2. Now I'm ready to simplify. 2 divided by 2 is 1. So the answer to this big old thing is just 1. Number 7. We have, first, we have to look for what's in parentheses. So in the numerator, we have an operation inside parentheses, addition. And in the denominator, we have something inside parentheses, which is subtraction. So we take care of what's in parentheses first. So negative 4 squared plus negative 3 plus 1 is negative 2 over 4 times 6 minus 8 is negative 2 squared. Next, we want to take care of exponents. I see that I have an exponent on the top. Whoops. The base of the numerator's exponent is 4, not negative 4, just 4. I also have an exponent on the bottom. The base of the exponent on the bottom is negative 2 because it's in parentheses. So in the top, I have a negative 4 times 4, which is 16, minus 2, or plus a negative 2. So this plus a negative, you can leave it as plus a negative 2, or you know that a positive times a negative is a negative, so you could just write it as minus 2. Either one is fine. So if you want to put plus a negative 2, great. minus 2, great. Either one is good. Okay, in the denominator, we're going to do the exponent, so we bring down the 4. Negative 2 times negative 2 is a positive 4. All right, now we have to look for multiplication or division. We have multiplication down here, so we'll do that. So in the numerator, I still have negative 16 minus 2, and in the denominator, I have 4 times 4, which is 16. Now I'm looking for any addition and subtraction, and that is what I have in the numerator. So negative 16 and negative 2 is negative 18 over 16. And now if you know how to reduce a fraction, you would do that at this point. So both of these are even numbers, which means they're both divisible by 2. That means they both have a common factor of 2. So I can divide them both by 2. Look and see that I'm dividing here by 2 over 2, which is just 1. If you divide by 1, you're not changing the value, you're changing the numbers, but it's still the same value. It still means the same. So 18 divided by 2 is 9, and I've got a negative, and 16 divided by 2 is 8. If you put these in your calculator and you did 18 divided by 16, you would get negative 1.125. Okay, so if I put it in the calculator, I would get negative 1.125. If I put this one in the calculator and I said negative 9 divided by 8, I would get negative 1.125. So notice that these are the same. It's just one is reduced. So you always want to make sure you reduce your fractions. So negative 9/8 would be what we would get for that one. All right, number 8, we're looking for parentheses. So I've got operations inside the parentheses here, operations inside parentheses here. Notice that in the bottom, it's just one number in the parentheses. So that's not really what I mean when I say parentheses. We're looking for operations in parentheses. So in the top, I'm going to have 2 open parentheses. There's actually 2 things going on in the first set of parentheses. I've got to multiply before I can do the other part. So 3 minus 12 minus negative 1 and a negative 3 is a negative 4 all over 13 divided by 3 times a negative 5. I still have something else to do in parentheses up here. I've got this operation, so I'm going to take care of that. So 2 times 3 minus 12, whoops, and I didn't take care of it. 3 minus 12 is negative 9 minus a negative 4 all over 13 divided by 13 times negative 5. Next, I'm looking for exponents. I don't have any, so then I'm looking for multiplication and division. So I've got this multiplication, and let's look at the top first, because the bottom, we'll have to talk about that. So let's finish the top first. So for the top, I have 2 times negative 9, which is negative 18. And then notice I have a negative times a negative. That's going to end up being a plus 4. So the 2 negatives back to back make a plus. So we're going to change that sign. It's kind of like having an understood 1 there. A negative 1 times a negative 4 is a positive 4. So I'm just going to put plus 4 to make it a little easier with the signs. Okay, now let's look at the bottom. So in the bottom, I have division, but I also have multiplication. Since multiplication and division are equal operations, I need to do them in the order they appear from left to right. So I need to do this division first because it's the one on the left. Keep in mind that you might be tempted to do the multiplication first because of PEMDAS, but multiplication and division are equal operations. So we need to do the 13 divided by 13 first. So we will get 1 times negative 5. All right, next, I'm still looking for multiplication and division. I still need to do this multiplication on the bottom. So on the top, I still have negative 18 plus 4 over 1 times negative 5 is negative 5. And then I'm looking for addition and subtraction. I see that I have that on the top. So negative 18 plus 4 is negative 14. And I have a negative 5 on the bottom. And two negatives in a fraction will cancel out and make a positive. So this is the same as 14 over 5. So that would be as simple as I could get it. All right, if you're still with me, you're doing great. The last section is evaluating expressions given the variables' values. So for number 9, we're asked to evaluate 3y squared given that y is 5. So all I'm going to do is plug in 5 where y is. So instead of y, I'm putting a 5. Notice I put parentheses around what I'm plugging in. That's just a good habit to have. So first, I have to follow order of operations. So exponents come first. So 5 squared is 25. And then I can multiply and get 75. Number 10, x is 2. So I'm going to plug in a 2. Plus y is 5. All right, so I'm going to have negative 2 plus 5, which means it's just going to be 3. Number 11, I have 3x minus y plus 7 times z minus 1. So my first kind of chore, I guess, is to plug stuff in. So 3x, x is 2, minus y is 5, plus 7 times z is 0, minus 1. It seems unnecessary to put all these parentheses, but again, it's just a habit that I like to get in whenever I'm plugging something in. It doesn't make a huge difference now, but if you're plugging stuff in and it's negative, and you already have a negative in your expression and or an exponent, it can make a big difference. So if I'm looking inside the parentheses, this first parentheses, I've got to do the multiplication before I subtract. So that will be 6, 3 times 2 is 6, minus 5. Plus, in this other set of parentheses, I've got 0 minus 1. Now I can do the subtraction in the parentheses. So 6 minus 5 is 1, plus 7 times 0 minus 1 is negative 1. Now I'm ready to multiply the 7 times negative 1. So I'll have 7 times negative 1 is negative 7. And then 1 minus 7 is negative 6. Okay, the last one, I have 3x squared plus 2x minus 8. So I'm plugging in 2 everywhere since I only have x's. So we'll have 3 times 2 squared plus 2 times 2 minus 8. So we'll take care of the exponent first. So 2 squared is 4. So 3 times 4 plus 2 times 2 minus 8. Now we'll take care of the multiplication. So 3 times 4 is 12. 2 times 2 is 4. Bring down the minus 8. And now we're going to add and subtract from left to right. So 12 plus 4 is 16. And then 16 minus 8 is 8.